Some of you might have seen, or some of you might use, a tennis ball hanging down from your garage ceiling to tell you how far to pull your car in so that you know it's in the right spot. Well, with technology, why use a tennis ball when we can make something more complicated but easy to use and make technology work for us? Today, I'm going to build something that's similar to those systems used at airports to tell pilots how far to pull their airplanes up at the gate so they're in the right spot. It's a very, very, very simplified version of that. Basically, just a color indicator telling us when we're far enough in. And yes, I say making it more complicated because you have to do a little programming and a couple of things here and there to make it work. But I think it's a cool adaptation of using something like an ultrasonic distance measuring device and a little atom matrix board to show you that your car is far enough in so you don't have to go outside and check and make sure that you're far enough in to close the garage door. So let's get started on that project. So let's first talk about the things you're going to need for this project. You're going to need the M5Stack atom matrix, the little display board that shows colors and various other things on its little LED display. You're also going to need the HCSR04 transducer, distance measuring transducer. It's an ultrasonic device that measures distance. There are two of those on the market, or probably multiple on the market, but I tried the like reddish orange one or red one, and that one didn't seem to work properly. The one that I was able to get to working was the blue one, and the blue one has the VCC indicator. It's a 5-volt version. The other one is a 3.3-volt version, and it has the quick connects. So don't use the one with the quick connects for this project unless you know how to make it work. You stick with the blue one, and that's the one that has the VCC indicator on the pin. And of course, you're going to need Visuino. Visuino is a software package that allows you to visually program Arduino boards. And it allows you just to connect everything without the need for programming anything at all. And for those of you that are purists, you can absolutely take this code and export it into an Arduino IDE editor. That's fine. And then tweak it to your liking. But for those that want to program this way, this makes it an easy way to put things together. And you can use it for all kinds of different projects, not just the one I'm talking about. All right, so let's talk about the pinouts real quick. The pinouts are just like this, just like my crayon drawings here. You're going to connect ground on the Atom 5 matrix to ground on the transducer. Of course, voltage, this is the 5-volt. You can see that here. This is the 5-volt line going to the VCC input on the transducer. There's also a 3.3-volt over here, but again, I was never able to make that other one work. You're going to connect the pin 25 of the matrix onto the echo pin of the transducer, and you'll put the pin 21 of the matrix onto the trigger pin of the transducer. Once you have all that connected, and you can do this in any order, you don't need to connect it. In fact, I would just wait to connect it until you're done programming the matrix. I've used the Atom Echo as well, so I get those two confused sometimes. I wouldn't even hook this up until you're ready to go at the end. Just keep this in mind for later on. It's in the blog post, which I'll link down below so you can see all these pinouts. In fact, everything I'm going to talk about is in the blog post. So if you are interested in going through those details, go there. I think they complement each other in this particular project because some stuff is easier to see visually, some stuff is easier to see by reading. So go look at that as well. All right, so let's go ahead and look at our Visuino. And this is how we're going to set everything up. This can get a little bit hard to see as I move around. Just kind of pay attention as I go through these steps. It's pretty simple. It's just hard to display it on a video screen as I'm doing this. So what I'm going to do is I'm going to start with this art. This is when you first start up, you get this Arduino or some sort of default board. We want to make sure we're using the right board for this. So let's go ahead and go with the right board. So let's select the board. This is going to be this drop down right here. So click on it, select a board, and you're going to search for M5, and you want the M5Stack atom matrix board. Obviously, that's what we're working with today. And that'll set this board up with the right pinouts, the right connectors, everything that this board can do. It can do a lot. It can do a lot more than what we're doing. It's an ESP-based board, so it has a lot of other functions. We won't use those today. Now what we want to do is we want to add some components to this. I'm going to call it the palette. There's probably a standard term, but I'm calling it the palette for today, so go with me on that. We want to add 4 different components. We're going to first search for Ultrasonic Ranger. Now, one thing to keep in mind about this side panel is the way I have it set up is it's the little icons with a list. You can view it different ways. I actually don't even know how to change it, but somehow I changed it to this. Probably this. Well, anyway, it may look different for you. You may have the big icons. The point is you can still search up here and find what you're looking for. We want the just standard Ultrasonic Ranger. You can either drag it by holding it and dragging over here or double click it. I'll just go ahead and double click it. And it will put it on this palette over here somewhere, and you'll see it over here. We're going to clear the search. Next up, we want the compare analog value. You'll see it show up in a number of different categories here. It doesn't really matter. Just grab one. They're all the same as long as these little icons look the same. And you can hover over it and see what the actual component looks like. Double click that, put it over. And again, somewhere on here, it'll show up. Next up, we want the detect edge, digital to clock one. So double click and that'll place it over there. And finally, we want the compare color value. And there's a bunch on here. We just want the straight standard compare color value. You don't want alphas or RGBWs or anything else. So double click that and put it over here. And it places it on here. Now these are all kind of tiny to see on the video. I'm going to go ahead and move them to the left-hand side of this board because that's how we're going to work with them. So just drag them over, let go, and it'll just kind of move it over. And I'm going to arrange this a little bit. You can actually arrange this automatically by clicking an auto arrange button here once you have it built out, but we're not going to do it that way. And now we're going to start configuring these things. So let me zoom in a little bit so you can see. The first thing we want to do is go to this M5Stack, add a matrix. And as you click these, you'll notice that over here on the left-hand side, properties show up. So we're going to go to digital. Actually, we're going to go to modules. And we are looking for RGB matrix. And we are looking for elements. And if you click on this, you'll see this 3-dot thing over here. You click on that, and it brings up the elements here. We want to drag fill screen over here to the left-hand side. And when you do that, you'll notice that it changes the property window over here on the left. We're going to make some changes to some of these components as we go along. One of the things I want to change here is I want to click this color right here, and I want to click on Alpha Color Sync Pin. And that's all we need to do for this one. You can close this elements out. On Ultrasonic Ranger, there are no changes to make here. And we want to click on compare value, and this is a compare analog value down here. We want to change CT equal to CT bigger. And on the value, this value is in centimeters, and this is how far out you want that sensor to cause a trigger. So let's say you want something out at 76 centimeters, which is where I want it. I would put 76 in there. And this will actually change the color of that little atom matrix to the other color that we're going to choose when it hits that, or when it crosses that threshold. So that's kind of the trigger threshold. So we've done the board properties. We've done the compare analog value properties. Let's click on detect edge, and we want to change a couple properties there. Let's go, or one property. Let's change this to false on rising. So that should be false. And that's the only one to change there. Now you'll notice here that I messed up here on this color value. So I have a compare value 1, which is the one we just set here. I have a compare value 2. That's not the correct component. So I need to delete that one, and we need to go back and find the correct color value. It's not compare color value. It's just straight color value. So instead of using compare, in your search up here, just use color and then drag this one over. And this should give you the ability to add a couple options. which it does. Okay, so when I double clicked on that, now I have the proper values. So make sure you're using color value, not compare color value. All right, we're going to double click this twice, set value 1 and set value 2. You'll notice up here it actually sets these as well, gives you a couple of inputs here. The first one we want to set the value to is, and you do that over here, you can set this one to, let's say red, or let's say green. And the second one you want to set to is red. Now, it doesn't matter what colors you use here. This is completely up to you. I'm just using red and green because I want, when the distance is too far out, it's green. And whenever the thing I'm going to measure gets closer, it'll turn red into that 76 centimeter range. So you have the two values there. That's all you need for that. So we've basically set everything. Let's just go through here. No changes on the ultrasonic ranger. We've set the color values. We've set the detect edge, and we've set the compare value settings. So everything should be set and ready to connect. Now this is the fun part of this. We're going to do most of our work down here in this fill screen area. So I'm just going to basically copy or select this whole group of boxes or components, and I'm just going to drag them down here. And I'm going to put them about right here. This is purely for aesthetic reasons. It doesn't matter to the programming how this works or how it looks. It'll still do everything correctly as long as you have all the connectors in the right places. All right, so we're going to start by connecting all these values together. Our ultrasonic ranger is our input that's going to do a lot of this stuff. And I'm going to further move things around a little bit. First, I got to get off of that selection. All right, move things around a little bit so I can see it. It's hard for you to see this on the screen because it's such a small area to work with. So I'll do my best to get it in here. All right, so what I want to do is I want to connect the ultrasonic ranger output to the compare value input. So this will go here. So you just click on one of these little squares and you'll notice it creates this little line and everything. You just click over here and click it and it will automatically make a nice pretty line for you. And I'm going to take the output, the trigger of this, and even if you click it and you start moving your screen around, it'll still follow you along here. I want the trigger for that to be on pin 21. Remember, I showed you pin 21 on the Atom is going to connect to the trigger, or the trigger on the right. Let me get this right. Pin 21 is the trigger on the Atom matrix. So we want to do that. And then Echo is the other pin on the Atom matrix we selected that we want to input into this matrix board. So we're basically giving inputs to the matrix from the ultrasonic transducer. And this is pin 25. And what's neat again is you just kind of do this, click on it, and it'll automatically make this nice line for you and format it pretty and everything else. So those are the connections from the transducer. Now we want to take the compare value output here, and we want to put it on the input of the detect edge. So get that over there, click it here. Make sure you click the square and then put it here. And if you don't like that, you can move things around a little bit to give it a little more room to make the lines look good, kind of like that. Kind of experiment where you want these. And in addition to that, we also want to set the color to green right off the bat. So we're going to create another connection to our green color here. And when it detects the edge from the transducer, we're going to make that actually set the color to red. So we're going to connect that there to red. Now, all of that's going on and doing all the color value settings and everything. Now we need to actually tell the board to do something. And that board is going to, or the colors are going to be set on this screen, this fill screen area that we set up earlier. We're going to take the output to the clock from there, and we're going to take the output to the color from there. So now we'll be able to set the color on the matrix board to what the color output is here, depending on the input that we send it from this direction, or from this detect, or from the compare value. So that's it for programming. everything is connected together. We've got our echo pin coming out of the Ranger. We've got our trigger coming out of the Ranger. We've got an output coming out of this component that's comprised of what's going on with the Ranger. We're comparing the value. And again, comparing value is this 76 right here. And depending on what it does, the output will either send it directly to the green or keep it green. If this value threshold is met, then it will send it over here to this detect edge, or the detect edge will get that and change the color to red. And then this sends it over to our matrix board to do the display. So now that you've done all that, you'll notice over here on the bottom right, I've got it hidden, but there's a whole section. When you first open it up, you'll see this little help section here as well. But you have it open here. If you've got it closed down, you just click this little red thing right here and it'll open it back up. And we're going to go ahead and build this out, this software, the way we have it programmed here. Now, one thing you notice here is that you have COM5 unavailable. In order for this to work properly, you need to make sure that you have your M5Stack board plugged in. So I've got it plugged in to the port now, and you'll see that COM5 becomes active. If you don't know what port this is in, just look at the ports you have here when it's off. And when you plug it in, either one becomes active or one gets added here. And then that determines which port your ultrasonic Ranger is actually connected to. So you can do that to determine the port. Once you have the board selected, which by the way, you want the M5Stick-C selected, you want the proper COM port selected, then you would just click this build or compile, build, and upload button. And this will compile it, build it, and upload it to your M5Stack. If you just want to build it, or if you just want to upload it, you can do that right here if you already have something in here. So I'm going to click on this, compile and build, and you'll see it go through. I have verbose checked for both of these boxes here. So you're seeing a lot more than maybe you would if you didn't have verbose checked. You can do that for debugging purposes if you want to. It doesn't take very long to actually compile this and upload it. So let me get a little sip of coffee while it's doing its thing. And it successfully built it. Now it's uploading it, and you'll see it go through the writing stage. And if everything is good, you'll have a success option right here. And if everything works the way it's supposed to, then you will see a green or red light, depending on, and it seems to wash out green. Oh, you know why? I have a green screen. So when it goes green, it just basically turns off in the back. But I've got the transducer here. And when there's the red because I'm pointing it farther than 76 centimeters. But when it finds something that's closer, then it will change it to green, which then washes it out on my green screen. That's kind of cool. So it is working now with it all connected together based on that setting we just set up. So that's basically it for programming this transducer to measure distance. Again, if you want to change the value here to something different, you can do that. There's literally thousands of use cases for using a transducer and doing something with it. I just happen to do the display like I showed, where I'm going to determine how far away the vehicle is from the wall, so we know that we're far enough in the garage to shut the garage door. So let me know what you think of this. Let me know if you have any specific projects that you plan to use with this, all that in the comments down below. A reminder that the associated blog post that goes with this is available too. It's also linked down below. So if you want to read about some of these steps versus watching on the video, or use the video and the blog both to kind of get an idea what I'm talking about, make sure you do that. Let me know if you have any questions. I will do my best to answer those. And yeah, thanks for watching. We'll see you on the next video.